All right, guys, let's talk about part four. Part four is going to be another one of those things where I'm not going to write anything down because the evaluation is really just going to be up to you to kind of formulate. We can have a nice conversation again, albeit a one-way one, meaning that you guys can obviously talk back to me when I'm talking to you. So we have this has like been framing our journey through geometry so far this year. Is that I have like this figure and I have the second figure, and I'm wondering if they're congruent. And really, I've been asking that question over and over again now for like 2 months. And you guys have been doing a really nice job putting this argument together. Like I know it's been frustrating at times, and it's been really, really high level stuff. Like really, just really to the edge of what we can do even in high school sometimes. Like we're definitely pushing the bounds of even like a college level kind of situation, because there are some college people and some even some teachers who have a hard time explaining this. So kudos to you for kind of persisting and kind of putting together this argument because I know you guys can. But let's kind of trace our journey so far. So if I want to prove figure one is congruent to figure two, and I threw this question at you guys, and you guys worked in groups to kind of help figure it out, the very first thing you guys did was basically trace it. You trace the thing, right? So you like whether you use an iPad or use some paper and some tracing paper, whatever kind of have you. Um, you looked at this and said, well, look, if I kind of put this kind of crude trace around figure one, and then I kind of cut it, and I put it over here. Oop, I cut it. Come on, guy. And I kind of put it over figure two. I can say, yeah, well, it kind of lines up. It kind of doesn't. But that was a really, really argument to tear apart. Like as soon as one person in any group did that, like basically the whole class was on them. They're like, no, that's no good at all. For a variety of reasons, like you're tracing by hand, or even if you trace by a ruler, how do you know it did it perfectly? There's just too many ways you can look at that argument and say, well, all you're really doing, guy, is giving me your best kind of opinion, because you can't really tell 100% for sure that you lined everything up correctly. Some people got mad at it, but in the end, that's the problem with this kind of argument, that it turns into an emotional, opinion-based argument really quick. By tracing, you just don't know for sure because there are too many holes in the soundness of that argument. So a quick evolution turned us to measurement. Like we actually broke out some of these tools and say, well, let's measure figure one, let's measure figure two, and if all the measurements turn out to be the same, they got to be the same too, right? Well, it turns out this argument has a lot of places for peril as well. Measurement itself is a kind of inky proposition, so to speak, meaning that you don't really know for sure if you're measuring perfectly. In fact, we as human beings, I would claim, we can't measure perfectly. Like, there's too many places that you can totally mess up where it's not lined up correctly, the ruler slips. And in fact, anybody who used measurement as a type of argument realized right away that you couldn't. Measurement was no good. Like, measurement, just like tracing, offered a really close opinion and gave us some evidence to think like, yeah, this could totally work. But in the end, measuring is no good either. So you kind of decided like you need a better tool, and so we kind of evolved our tool to the compass, which turned out to be pretty good for us because it was a more precision tool, but it wasn't without its problems also. Like so, this was still built based on your human ability to measure and trace and eyeball really well, and even though it produced like a nice copy for us that is a whole lot more believable than maybe like the ruler or the protractor above. A compass based argument by itself still isn't very good, because in the end, like once you make something with a compass, you can't measure it anymore. The compass is a making tool, not a measuring tool, which we use several times in class, right? So even though this makes a nice copy, you still can't tell anything about the copy. So tracing is no good because you just don't know if you're doing it right and it's not very precise. Measuring, there's too many places to make mistakes. The compass is great for making stuff, but not for telling what's true afterwards. But I think the real joy here joy quote unquote, came when you started bringing in other structures. So if you use a compass and the fact that it makes a circle to pull in another item, like for in this case, if I want to prove these are both trapezoids, using say like a isosceles trapezoid, this was ultimately the best way to do it. And I knew we used kind of a silly analogy in class about like what happens if like your group of friends like this girl over here, you're gonna send the guy over to talk to the girl and blah blah blah. But the whole point is like you're always looking for that thing. So like if it turns out we have like a really nice list of things to work with, quote unquote things, that do very specific tasks for us. So like if I want to show or prove parallel, I'm going to bring in an isosceles trapezoid because that's what it does for us really, really nicely. Like if I have this isosceles trapezoid, I know for sure that these are going to be parallel because of what I know about trapezoids. So automatically, if I can construct an isosceles trapezoid, kind of like you're seeing up here, I know the top and bottom of figure 2 are parallel, just like they should be in the original. Same kind of thing here. Like if I want to prove something's perpendicular, I'm going to construct a kite. And it's for the same kind of reasoning. Like I know for sure that these two pieces in a kite are going to be perpendicular. So if I want to, if I need to prove something perpendicular, I can superimpose a kite, and I'm good to go. There's a couple more that we talked about in class that's worth mentioning. Like if I want a perpendicular bisector, what I'm going to bring in is going to be an isosceles triangle. Because of what I know about isosceles triangles. Whoa. Okay. Okay. Because what I know about isosceles triangles is that, okay, there we go. Okay, so what I know about isosceles triangles is that this has to be a perpendicular bisector of the base. So if I can construct an isosceles triangle over the top of it, using some nice sweeping circles, kind of like this, then I'm totally 100% in business. Okay, and we have a couple more for our list. Like if I want an angle bisector, then I really am just bringing a kite. So like if I have this angle I want to cut in half with this line, again what I'm going to kind of bring in is a kite structure because that's going to cut it in half for me. So that's kind of that's kind of like the end of the road for us. Like so when we kind of progress past this unit, this will be the direction we're going. So like we're not going to be doing the work ourselves. We're not going to force it by doing some kind of crude measurement. Instead, we're going to find like a thing that does it for us. If we want an angle bisector, bring in a kite. If we want if we want parallel, bring in an isosceles trapezoid. If we want perpendicular, bring in a kite. If I want perpendicular bisector, bring in an isosceles triangle. So that's kind of the way we're proceeding forward. It's everything to do with finding facts and not opinions to support our arguments. Because I would argue like these are opinions, these are no good. These guys are the facts. These absolutely work, and we can't controvert them. So that's going to be the end of part 4. Again, formulate your argument based on our discussion, based on what you know in class. And again, if you want to check it, make sure you have them ready before your test, and we'll run through them. We'll see how valid the argument is that you're building. So that concludes part 4. I'll see you all in part 5.